Hey, this is Marvin. Welcome back to another Unity tutorial, and in this tutorial I will show you how to build this piano roll with several octaves of notes. And the best thing about it is we also have sounds. In this tutorial I will only show you how to generate very basic sounds, but there will be another tutorial where I show you how to generate better sounds with it. So at the moment it's like that. I click on a note. I will just make the sound a little bit louder. That's it, very basic sounds, so you can play whatever song you like, and I will show you how to do that. Before we dive into Unity, I just wanted to cover some basics about a piano roll. So I've just opened an online virtual piano here to demonstrate some things. You may notice that we have some white keys and some black keys. And the black keys are called the sharp notes. So we have a C note here, and then we have a C sharp note here, a D note, a D sharp note, and so on. And another thing which is pretty important to mention is that we have notes from C reaching all to the note B. And after the B, we are coming to the next C note. And basically the notes from C to B, all that 12 notes here, are called an octave. And after we've hit the B note, we just start with another octave, which is going from C all to the note B. And that's basically it. So on a piano roll, we have like 7 white notes, and we have 5 sharp notes, 5 black keys. Okay, we just start with a new Unity project. So I click on New Project, and then I select a 2D template because we only wanted to work with 2D UI elements at the moment. And I will create the project, give it a name like Piano, and just wait some time. Here we are again. After some waiting, you should see that screen here. The Unity project has just finished to create, and I've also opened my favorite code editor, which is Visual Studio Code, with the project, so we are ready to go. The first thing I wanted to do is prepare the scene or the user interface. Basically, we wanted to draw the piano tiles into a canvas. So the first thing we will create is a canvas, and we also will change the UI scale mode. So at the moment it's set to constant pixel size, which means when we change the resolution of the screen or you just try out the project on another device, then the whole user interface will look different. And because we wanted to have a responsive piano roll, we set this to scale with screen size, which is the better option for our purpose. The next thing I wanted to do is I wanted to create an image which will be our container for the piano roll, where we put all our keys into. I will just name it piano, and I will resize it properly. So I wanted to have a piano roll which is going all the way from the left side of my screen to the right side, and because of that I will just resize it properly and will give it a gray background. The next thing is we will create a black and a white piano tile. We will create an image for that, saying, okay, that is our white key. I will just resize it a little bit, but it doesn't matter too much because we will resize it programmatically later in our script, but just it looks a little bit better now, looks a little bit more like a white key. We will resize it right now. And then we will also create another image, which is our black key. We will give it a black background, obviously, and also resize it a little bit, and also change the height. Yeah, like that. And the black keys are a little bit smaller than the white ones, so that should do the job. Okay. Another pretty important thing is we wanted to set the anchor position of our images to the top left side, so we can set the position better later in the script. I will explain that later, and we will just clone all this the white and the black tile, put it into our piano container, and then set the position properly. Okay. So we have set the anchors properly, and then we also wanted to have a script which is called, let's say, piano tile. And this script should contain the information which key it is actually. So I will just open that script with my code editor. Oh, that takes some time. Let's see, give it another try. Okay, here we go. We can delete all the things here, and I will just put one public variable into it, public integer MIDI node. And this script is attached to every white and black key we will generate later, and we can just put the information about our MIDI node into that script so that we later know which key represents which node. Let's start with actually create our keyboard script. So we go to the main camera and attach a new script to it, which we call keyboard, create it, and double click on it to open it in our code editor. Oh, let's see, that will take some time, obviously. Just wait. Okay, and here we go. That's our script we've just created, and the first thing we wanted to do is we will create some public variables which we can assign through the inspector later on. So we wanted to have some game object there, one which is the black tile and one which is the white tile we have previously defined in our scene. We also want to have a container, or the container which is holding all our piano keys. We have already defined it in our user interface, and we will just assign the game object to the game object in the script later on. And another public variable we wanted to have is the number of octaves we wanted to see in our piano roll. We can just adjust it later on in the inspector and say, oh, I wanted to have 4 octaves, or I wanted to have a piano roll with 6 octaves. So we make this flexible. I will just save it. Go back to the Unity editor. Oh, that will take some time to compile, but here we are. And now you can see that we have a keyboard script with some empty variables. We will just drag and drop the white key. We'll assign it here to the white tile. Black goes to the black tile. We also have our piano, or the container, which we wanted to assign here. And we will define the number of octaves for now to, let's set it to 5, because we wanted to see 5 octaves. That's it. Another pretty important thing to mention are MIDI nodes we will use right now. So I've told you about all the notes we have on our piano tile before. So we have C, C sharp, D, and so on for each octave. And the idea is that we also have an ongoing integer number, which is called the MIDI node number, which is representing a note in an octave. So when I scroll that table down here, you can see that we have a C note in our first octave, which is represented by the MIDI note number 24. So for each note, we have a number assigned to it. For C1, we have 24. When we go one octave higher, which is a C in the octave 2, we have 24 plus 12, which is 36, and so forth and so on. Because we wanted to start our octave starts with a C note, we wanted to set our start note to 24, because we wanted to start with a C note in the first octave. So we will define a variable for that called start note, which we set to 24. And then we will create a for loop to create all the octaves we wanted to see in our piano roll. We wanted to have a for loop which is executed until we reach the number of octaves. And for each octave, we wanted to call a method createOctave, where we wanted to pass the actual start node of that octave, which we can calculate when we just take our start node plus the current octave, our I variable, times 12, because we have 12 notes per octave. And the second argument we wanted to pass into that method is the actual octave, which is represented by our variable I. Okay, here we go. And now we will create that method, private void create octave. And the first argument is the actual node. And the second argument is the octave we are currently wanted to create. The first thing we wanted to do in that method is we wanted to calculate some values we will use later. It's pretty important to know the width of our container element. So basically what we wanted to know is the width of this gray image here, because we wanted to place all our black and white tiles inside of that gray image. And to do that, we will access our content game object. We will need the rect transform component, access the rect here, and get for the width. And we also wanted to know how many pixels or how much space we have per octave. So we define a variable called width per octave, and we take our previously determined width and divide it by the number of octaves we wanted to see. And we also wanted to know the width per node, which we can simply calculate when we take our width per octave divided by 7, which is a little bit tricky to get because we only have 7 white keys. So basically we wanted to have space for 7 white keys in our octave, and the black keys are between the white keys. So the width per node is the width per octave divided by 7 white tiles, you can say. The next thing we wanted to do is we wanted to create some tiles, and we first wanted to create 7 white tiles, and for that we will create a for loop. We will go from 0 all the way up to 7, and for each iteration we first wanted to determine the actual node index. We determine that by calling a method called getWhiteKeyIndex and pass our variable I to it. So basically we're going from 0 all the way up to 7 to generate our white keys, but we also wanted to know the actual number of the node in our octave, and that's not the same as this counter here, because we have also this black tiles in between all these white tiles. So the first node we're starting with is the C node, that's the first node in our octave, and the next white node is the third node in our octave. So there's a gap in between. So we have also this black keys here, and we wanted to get the index of the white keys. And to do so, we create a method called getWhiteKeyIndex, where we pass our variable E or I into, and we are going for actual node index equal to 0 in the beginning, which will mean it represents the C node, because the first node in our octave is a C node. And then we create a longer if-else statement to determine all the other indexes of the white keys. The first case would be that I is equal to 1. And that means it's the second white tile in our octave, which means C, D, it's a D node. And the actual node index should be 2, because it's the third node in our octave. So the C, the first node in our octave, got the index 0, then we have a black key with the index 1, and then the D node, the next node, will get the index 2. And we will continue to do so with all the other white tiles in our octave. I will just create that method and skip it in the video to don't bother you too much. I've just finished to create this method, so basically we are going through all the possible indexes and assign a proper node index for that. And in the end, we return that node index, and I've created a method called black key index accordingly to the method I explained previously. And here we go for the black tiles basically and determine the proper node index. I've just recognized we better should call that variable here not actual node, but it's a start node. That makes things a little bit easier to understand, I guess. Start node of our octave. The next thing we wanted to do is we will create a new node image from our white tile preset, you can say. We wanted to call a method we can call instantiate node. We pass the white tile to it. We also pass the actual node index and the start node to it. And then we will create that method. So it's a private method and it should return a game object. It's called instantiate node. And as parameters, we have a game object called node. We have an integer actual node index. And we have an integer, which is our start node. Then we just need to clone our node because we have passed the white tile preset here into that method, and we just wanted to clone that. And to clone things in Unity, we just can use a method called instantiate, where we pass our game object we wanted to clone, and now we have a cloned game object. The next thing we wanted to do is we wanted to set the new parent to the node we have just created. So we use transform.setParent method, pass the container transform because we wanted to have the node a child of the container element. And we also set this parameter to false because we wanted to have the node to be scaled accordingly to the parent scale. So just set it to false to get the proper scale here. And we also wanted to assign the correct MIDI node to our newly created node. So when you remember, for the, where we have it here, let's see, where's Unity here? For each of our keys, we have a component called piano tile we have created previously, and we have a slot here for the MIDI node we wanted to save. And we will just set that MIDI node right now. So we want to get the component we have just created, the piano tile component, wanted to access the MIDI node, and we wanted to set the MIDI node to the start node of that octave plus the actual node index, which is our current MIDI node. And at the end, we just return our newly created node. Return new node. That's it for that method. Okay. So we've just cloned our white tile here and assigned it to a game object called node. And the next thing we wanted to do is we wanted to detect if someone has clicked or released the current tile. And to do so, we will pass the node game object to a method called register events. And we will just create that method. It's a private method. We don't want it to return anything, so it's void. Register events. We will pass an argument from type game object to it. And now we will work with event triggers to listen to events. Event trigger. Normally you just need to import that as well. So basically I've just added that before, sorry for the confusion. So basically you just need to add another namespace to the script. You say, hey, I wanted to use Unity engine.event systems. And then here we are ready to go to use our event triggers. I will just add a new trigger, and I do so by access the game object, say add component event trigger. And then I need to create an event for pointer down and pointer up. I will create a new event trigger .entry for that. And now I can just access the event ID, which basically defines what kind of event we wanted to listen to. And we say we wanted to listen to event trigger type dot pointer down. And the next thing is we will add a callback. So we say pointer down dot callback dot add listener. We will pass an event to it and say, okay, whenever the pointer down event fires, we will just call a method called key on, and that method does not exist, but we will create it soon. And we just wanted to pass the MIDI node to it because we wanted to know which node was actually clicked. And to do so, we just access our node game object, say we wanted to get the piano tile component and access the MIDI node. And that's it. And we just need to add the trigger. We do so by say trigger.triggers.add pointer down. Okay. We will just do the same for the pointer up event. I will just do that once again. We say pointer up is equal to event trigger.entry because we wanted to create a new event trigger entry. Then we will register, or we will just define an event ID, which is from type event trigger type dot pointer up, because we wanted to listen for the pointer up event as well. And then we add another callback, which we do dot callback add listener, and then just call another method, which we will call key off. And to the key off method, we also wanted to pass the MIDI node of the tile which the user has clicked. MIDI node, and here we go. Okay, the next thing we wanted to do, I've forgotten to add the trigger. So we also wanted to add the pointer up trigger. Pointer up, okay. And now we just create these two methods. I guess because we have we wanted to call the method from the event listener, we need to make them public. So just go for a public void key on in MIDI number. We'll just create a log for that right now, debug.log clicked MIDI number, and we will do the same for the key off function. Key off int MIDI number, and also do a log here and just say released plus MIDI number. Okay, and that's basically it for registering the events. So whenever someone clicked on the node we have just cloned, or on the tile we have just created, then we have added some event triggers, and they will call the key on and key off method with a proper MIDI number. The last thing we wanted to do here is we wanted to calculate the width of the white tile and also the position on the piano roll. And we go first for the width, and to change the width of our node, we can access the rec transform component of our node and change the size delta variable. We assign a new vector 2 to it, and here we go for the width of our white tile. And We have calculated that previously. We have just calculated a variable called width per node, which we can simply pass here. And we can subtract 1 pixel from it. So we have a very small gap between each the white tiles. And for the Y component, we just stay with what we got. So we access the rect transform again, use size delta.y, and that's it. It simply remains the same. We don't change that attribute. And the next thing, which is pretty important, is we wanted to change the position. So we wanted to align the white tile properly in our piano roll. And to do so, we will also use the rect transform component and change the anchored position 3D, which is a vector 3. And pretty important is the X and the Y component. So we can calculate the X component or the X position when we just use our width per octave multiplied by the current octave we are in, plus width per node times I, because I is the index we use to iterate over all the white tiles in 1 octave. And to align the whole thing, so to make it aligned properly, we also need to add width per node divided by 2 to center it in the middle, let's say. Okay, so that's for the X component. And then for the Y component, we take our white tile, use the rect transform component, rect transform, access the rect.height divided by 2. So we wanted to set the Y component of this to the middle of the white tile, let's say. And the Z component does not change. We will just leave it as 0. And here we go. That's basically the position for the white piano tile. And we can just test it. I will save the whole thing. And now here we go. Click start. Yeah, and here we are basically for all our white tiles in our piano roll. And when I click on one, you can see that we have the event listeners, which listening to the events. So when I click on that tile, you know, oh, okay, he clicked on the tile with the MIDI node number 74 or 64 and so on. And that's it for the white tiles, and we will do the same for the black tiles as the next step. We are ready with the white tiles, and now we go for the black ones. It's basically all the same as we have done before with some smaller changes. We also iterate with a for loop, but there are, 5 black tiles. You can see that when we just go, can I bring this over to the other screen? Let's see. Yeah, here we are. Basically we have only 5 black tiles. So 1, 2, 3, 4, 5 per octave. And that's the first difference. So we wanted to iterate from 0 all the way up to 5. We can also get our actual node index here. Actual node index. But this time we will use the get black key index method, which I've created previously. We wanted to instantiate a new node. We can use the same method as we have used for the white tiles, but this time we will just pass a reference to the black tile we wanted to instantiate. We put the actual node index and the start node into the method. And here we are with our newly created black tile. We also wanted to register the events for this node, and the next pretty important thing is we wanted to set the width of the black tile. We do so by accessing the rect transform component, and as we have done for the white tile as well, we just change the size delta here, creating a new vector 2, and this time we just wanted to set the width a little bit different, because when you look at the tiles here, you can see that the white tiles are way bigger than the black tiles, and that's the reason why we just use half of the width. We have width per node and divide that by 2 to get our width for the black tiles. And then for the Y component, it all stays the same as before. We don't change that. Rect transform dot size delta dot Y. And here another kind of tricky part comes in, because you can see we have kind of a gap here. So we have the first black tile, the second, and then we have a gap here between E and F, third, fourth, fifth black tile. And because of that, we just wanted to add another variable called black index. We initially set that to I, and whenever our index I is greater than 1, which means that we are at a black tile greater, or we wanted to instantiate a black tile here, the third, the fourth, or the fifth, and then we wanted to add 1 to the black index, because we just wanted to have this gap here. So basically, when we wanted to create a black tile, which is this one, or this one, then we just add 1 gap here. So that's the reason why we just add 1 to the black index. And now we can just calculate the position accordingly. We do it as we have done that for the white tiles, with some smaller differences. We also access the anchored position 3D and assign a new vector 3 to it, where we just take the width per octave multiplied by the current octave we are in, plus width per node multiplied by black index, which we have calculated previously, plus width per node, because we wanted to have a little offset width per node. Okay, that's it. And we can also calculate the Y component of the position, which we will do as we have done previously. We will just say we have a little offset. We use a black tile dot get component rect transform dot rect dot height divided by 2. So we wanted to have a little offset, half of the height of the actual black tile, and the Z component still remains 0. So that's it basically for the black tiles, and now we can test that and give it a try. Hopefully it all works. So it's just compiling, and then I wanted to change another thing, because at the moment we have this black and this white tile, which we clone and put into our piano roll, and we don't want to have that on our screen actually. So I will just move it a little bit away from our viewport. Okay, just save it here and give it a try, and let's see if it's working as expected. Yeah, and here we are. That's it. So we have a piano roll with all the keys, and when I click on a white one, you can see that we trigger the proper events for it, starting with a C, MIDI note number 24, then the black tile is MIDI note number 25, 26, 27, and so forth and so on. And that's basically it. And the next thing I will show you is how to add sounds to it. For the sound generation, we will just use a script which I've written before for a university project. It's based on audio filter read method, and I've linked some resources I've used to learn about this in the actual script. But for now, just create an empty game object, create it and call it SoundGen or whatever you prefer. Go for a new script, which we call also SoundGen. Open that in Visual Studio Code, and I will just copy over the code I've written previously for the university project. And here you can see that we have this on audio filter read method, which is basically changing the audio buffer accordingly to the frequencies you wanted to create. And we also have which is pretty important, we have an on key method, which expects the key number we are just pressing, and we have an on key off method, which also expects the key number we just released. And with all that, we can just save the whole thing, go to our keyboard script, and call the methods accordingly. So we are going for GameObject.find SoundGen, wanted to get the component SoundGen, and we have a method on key, which is expecting a MIDI number to generate a proper sound. We can do the same for the key off method, where we just change the method call here. And now we are ready to go. Okay, so here we are with our generated piano roll, and when we click on a tile, you can hear that we're generating some sounds. They are pretty basic. I think the end of the sound, when I just release the key, it's a little bit harsh, so it would be better to have a smooth ending of the sound, but it's just the first draft, and in the next tutorial I will show you how to generate or how to add the sounds in a better way so that they are sounding better and like a piano. But for now, that's the result of that project. You have a piano roll, you have all the notes which are playing when you click on them, and yeah, I think you can go crazy with the project, adjust it the way you like and add new components to it. I hope you liked the tutorial. You would really help me with subscribing and like the video. I've also created a GitHub project for it. I will just put it into the description so you can check out the code by yourself without watching the video, and hope you will enjoy to create your own piano roll.